So I'll go through most of the little questions they got on here. It'll kind of go into the next page too, between 47 and 48. It's the same picture. But there are, the reason I'm picking this out, there are a few good things to pull out of it. Plus, it's going to give us a couple definitions with what you're filling in there. All right, so it's got a picture where you've got a circle, and then there are three angles there. There's angle A, which is acute, angle B is obtuse, and then angle C down here would be the straight angle. Okay? So to start with, how many degrees are in a circle? 360. Which again is good because that's the angles that we work with that have to be in between 0 and 360. Because if you go all the way around the circle, you're essentially back to 0, and as soon as you pass that, you go back into the acute range. So that means if the whole thing is 360, if I take this angle here and add it to this angle and add it to that angle, I create an entire circle. So if I take the measure of each one of those two, the acute one, the obtuse, and the straight that's there, it's also going to give me 360. Because again, all those three together, if I trace out their little arcs for those, it's going to make a complete circle. All right. How many degrees are in a half circle? 180, right? Because that's that straight angle that's down there. Cutting that in half gives me the 180. Okay? And then again, if this right here, which I know this is a straight line, so I know if this is 180 degrees here, how many degrees is it across the top there? It's also 180. Okay? Which is that one right there. Now, the reason they pull this up is not only to show you that, hey, the angle measures are based on angles from a circle, like how far these arcs are, but it also gets to a point here where, I don't know the order of the questions next, I probably haven't, but I don't care about that. If you take two angles and you can put them together to be 180 degrees, those are your supplementary angles. Okay, so supplementary angles are always the ones that add up to 180. Now, the one downfall with this picture is these two angles, looking at the picture, these two are like right next to each other. You can see they're joined together. Supplementary angles do not have to be connected. They can be completely apart. The only thing that has to happen for supplementary angles to be classified that way is that their measurements have to add together to be 180 degrees. Okay, so if you need to write a side note also with this for definition-wise, write that supplementary means that it's two angles that have a sum of 180. So they have to add up to 180 degrees. Okay? You'll also note that on this right here, it's got a blank for a pair. I'm going to come back to this later, but if you want to fill that in, these are called a linear pair. Because it's a pair of angles that when you put them together are forming a straight line at their base, like the two rays that come off from the bottom are forming a straight line, so they are classified as a linear pair. Okay? This would be where you put the supplementary part if you want to do it. And the degrees would be 180 degrees if you're filling that in. All right, and then to build off the supplementary thing, I know the picture doesn't necessarily correspond to it, but if you go to the top of the next page or somewhere on that next page, on page 48, you see the question that asks what a quarter of a circle is. Right, so a quarter of a circle would be here to there, which would be your 90-degree angle. Okay, so the quarter circles are always going to be 90 degrees, which would be it's right there. And that would be, for filling this in, that would be a right angle that you put in there. Okay? Now, right here where it asks for two positive angles that together form a right angle, that's saying that if I took angle 1 and angle 2 and added them together, they're giving me 90 degrees. That's the complementary angles. So two angles that are complements of each other are two angles that will add together to be 90. Two angles that are supplements of each other would be, you add them together and they're going to be 180. Again, these don't have to be right next to each other. Like I could take I can say here's angle A that has a measurement of 40, and then over here, I got angle B that's a measurement of 50. They're not connected, but if I took this measurement and this one and add them together, that gives me 90, so I could say angle A and angle B, based on what I draw right there and have marked, are complementary angles. So just keep that in mind with this classification. Supplementary and complementary, they don't have to be next to each other like they have in the picture there. Okay, that's only set up because those, when they're connected, those the A and B are there also make a thing called a linear pair. But I'm going to have that definition up in a second. Not right now. Okay, but so you just got to get that down, right? Complement is the 90-degree one, supplement's the 180-degree one. And I know they always get mixed up. Okay. All right, next thing we're going to talk about is the addition. Now, I just did angle addition. When we did the part where it was like the A plus B is 180, like taking the two smaller ones and putting together to make a larger angle, was technically angle addition. I'm sure this is somewhere in your book. I don't know what page it's on because I like going through it my way better. So the postulate, you need to either write down or reference. If you want to search through the book, you can. But the idea with this, we did segment addition postulate back in the first section. Right? And segment addition postulate just said if I take two segments, add them together, it's going to make a bigger one. Same thing goes here. If I take two smaller angles and put them together, it's going to make a larger one. All right, so that I understand that if I take this angle here, which now, see, they've got the three letters, right, because this is not just a single angle at that vertex. There's three angles at that vertex. So if I'm taking this angle here, which is RSP, and combining it with the PST, it's going to create a larger angle, which again, it's a postulate. And again, anytime you see postulate, it's like a common sense kind of thing. It's something you could probably reason out on your own. Like your brain should work with an idea that if I take two smaller things and put them together, it's going to create something larger. Which is really all this is talking about. It's just the things that you're putting together are angles. In the first section, it was segments. But still, if I take two smaller segments and put them together, it's going to make a larger one. The problems that you'll see with this are going to be very similar to the segment ones in the idea that I'll give you parts. Like you'll have some variables in there you're going to have to solve for, so you're going to have to set equations up, and the basis of your equations are going to come from this here. You're not going to have RSP and PST and RST and all those letters there. The idea is, keeping in mind that this part right here, this is the larger angle. So the biggest one goes here. Those are always your two smaller ones if you're setting problems up. So it's always got to be the two smaller ones together are going to equal the bigger one. Okay? Can I go past this? All right, so for example, if I do that one right there, where I've got some expressions up there on my smaller angles, like there's an algebraic expression there and there. And at the same time, I give you what? Here, I give you a measurement for the entire thing. So from here all the way over to here, I know it's 155 degrees. Okay, so again, the idea is like if your brain looks at it, you should be able to understand that if I take this angle here, this smaller one, and combine it with this smaller one over here, and I like shove them together, it's going to give me that entire thing. Okay, so if I wrote it out with the postulate that's there in the letters, I can take this angle here and get rid of that. This is RQS. So if I take that angle there and add it to SQT, which is SQT is the other one, I'm going to get RQT. I'll get the big one. All right? And writing it out with letters is going to be, you're going to have to understand that. But still, this is the idea that this is a small one, that's a small one, that's the big one. If you're just trying to solve it for x's or things like that, you can just keep that idea in your head. Now, they've got things marked for each one. Like this is RQS, That's SQT, and then we already said RQT, the entire thing was 155. So you just fill in what they give you up there. It's 4x minus 20. 14. And then you got a single variable expression. You should be able to solve that equation there. I mean, all right, so if I combine like terms, that should give me 7x minus 6 equals 155. 7x equals 161. It's 161 divided by 7. 23. Okay, now, one last thing with this problem. All right, and we did this with segments also, right? The actual question is asking for the measurement for this angle and for that one. Okay, so when you solve for x, for this particular problem, I would not be done, because it doesn't just ask for the value of x. It wants you to take that, plug it in, to both of them, and then once you plug them in, do whatever you need to do in the calculator, you should get two measurements back, then you would be done. So if the problem asks for measurements, you got to make sure you take the time to go from your x value, plug it in, and then you'll give your answer there. So what's 4 times 23 minus 20? What is it? 72. What about that one? And 72 plus 83 does give us 155, so that means we didn't screw anything up. We're good to go. All right, next thing to talk about, guys, is on page 53. You can write along here. This is going to be your way to define adjacent angles. In general, like in any class, the term adjacent just means next to. Right? If you're sitting adjacent to someone, that means they're sitting right next to you. Okay? Means the same thing here. But when you say adjacent with like angles and other shapes in here, they're going to be connected in some way. So to be right next to each other, they have to be in some way overlapping. Adjacent angles, their overlap will always be this common ray that it's asking about there. The reason on that page they're asking for this common ray is that if you have a common ray, which would be this one right here, because this ray right here is a side for both this angle and this one. Like this ray is part of both of them. As long as you have a common ray together, you're creating an adjacent angle. Like the linear pair that was up there, those were adjacent angles. Okay, that common ray was whatever was creating the middle part there. All right, so if you need to fill this in too, this is adjacent. Make sure in some way you write down definition-wise what that is. Only because for the linear pair part, even for some of the angle addition stuff, when they do like a bisector, you're going to see the term adjacent comes up. So you're not completely lost on what the term means, right? Adjacent's still going to be next to, it's going to have a common ray there. So you kind of need it for setting up problems, and you're also going to need it for reading definitions properly. Okay? All right, so I'm going to do an angle addition problem that also includes this. It's not in your book, but you're going to have to, I would suggest you write it down. All right, can I go past this? Okay, so I'll do this one right here. What you'll notice with this problem is that there's no diagram drawn. If there's no diagram drawn, guys, draw it out. Do your best to draw it out. All right? I can like read through there even if I don't interpret everything at the beginning. Like you can draw something at the beginning and then alter it as you go. But like if I saw this and I see, oh, angle LAP. I don't know what it looks like, but I'm going to draw an angle that's LAP. Okay? So I know at least I'm working with that because that's what I run into right here. Then it goes, all right, LAR. Well, I should stop myself. It says it's adjacent, but LA is in both of them. It's the first letters there. So that's telling me that this ray right here, this is the common ray between them, okay? Because those two letters are in both of those angles, so I know that's the overlap there. All right? So that means that, what's the other letter? R. So I'll draw it out here. Again, it's not drawn to scale because I don't know how big it is. They don't tell me anything about size. But I can see that if I take these two right here and put them together, it's going to create the entire thing. Like if I take angle LAP and angle LAR and put them together, that's going to give me the entire thing. Okay? Only because I knew what adjacent meant, and I recognized that LA was in both of these, so I would recognize that that's the common ray. Okay? Now, if you read through the rest, they give you expressions for each one of those. So they're giving me what LAP is. So that's the 3x plus 7. All right, so all I'm doing is I'm taking this equation down here and filling in the information they give me. Okay, so I know LAP was the 3x plus 7. The LAR that's there, that's the 4 x minus 4. And then the PAR part is that. Again, you're back down to an equation now. It's asking me for the measurement. For me to find the actual measurement, I need to know the value of x. I've got an equation that I can use to find the value of x. Okay, so if I solve this out, what's the first thing you think I would do? Yeah, so if I distribute those in, that gives me 4x minus 16. That's 6x plus 14. Then I would probably, I don't know, combine like terms just to make it look nice. So that would be 7x minus 9, 15. Then what else? What would I do next? By doing what? Subtract what? 6. So I'll move the 6x over. And then what's the last step for me to get x? So do what to it? So add the 9. So I get x equals 23. Again, look at that. Okay? So now again, like on the last problem, it doesn't just say find x. So it just says find the measurement. So I got to take the value of x, right? And I got to plug it in. So LAP would be 3 times 23 plus 7. Oh my gosh. LAR would be 4 times 23 minus 4. What is that again? 3 times 23 plus 7.
83.
What?
It was 83.
83? What is that? Some new. 3 times 23 plus 7? They're guessing, so that's why I need someone to actually verify here.
76. 76.
So there's one answer, and then 4 times 19 would be the other. Because I got to do 23 minus 4 first, then I got to multiply. What's 4 times 19? Oh, look at that. Okay. All right, so the result also from this, we could throw in there. Since I know this is not drawn to scale, but since these are both 76 here, that means that these angles are congruent to each other, which also means that this thing right here, this ray, this ray AL, it bisects that big angle, which we'll talk about probably in the future. But if you see two things that are equal to each other in angles, that means that that ray down the middle will always bisect it. All right, so like I said, I already had the term up there, right? We had it earlier with the little circle thing, but I want you to, I'll give you a definition like off to the side for a linear pair. So a linear pair, there's two things that has to happen. One thing is that one thing with a linear pair that has to happen is that they have to be adjacent. So they have to be connected for each other to be considered a linear pair. Because what that means is it's a pair of angles that are forming a line. Right? So linear would mean forming a line. Pair means you got two there. But they have to be adjacent angles. They have to be connected. If they're not connected, you just say they're supplementary and that's it. So the first thing is adjacent. The other thing is that they have to be supplementary. Okay, a line always has 180 degrees, so if you're creating a line, it means that you're creating two angles that have a sum of 180 degrees. So that means like the two angles over here, like this angle, 1 and 2, those would be a linear pair. Because again, if I take this side, if I take this angle and put that one together, that gives me a half circle, which is 180 degrees. On the other picture that's over there, which I'm going to use for the next term also, you've got multiple linear pairs you could match up, like angle 2 and 3 would be a linear pair, because the bottom of it would be a line, so your 180 would go this way. 3 and 4 would be a linear pair, 1 and 4, 1 and 2. You've got multiples there that are straight lines, okay, or that would come together to create straight lines. But keep in mind, but I want you, just in case, I don't remember if the actual book in there had it, so if you're looking through the book for a definition, make sure that you have linear pair has to be adjacent angles. Okay? Because again, if they're not adjacent angles and they add up to 180, they're just supplementary. And that's it. All right, and then like guys, the last thing I want to talk about, and I'm going to do one problem with this last thing. Oh, is it fine if I go on? Do you need me to go back? All right. So last thing is going to be vertical angles, which these are going to come up quite a bit, or they should come up quite a bit. Vertical angles are going to be angles that are formed by two straight lines intersecting, and they're always going to be opposite each other. Vertical doesn't necessarily mean like straight up and down. So again, that was the last picture I had up there. It could be side to side. But the key thing here is, again, two things. They have to be formed by two lines intersecting. And they have to be opposite each other. Like 1 and 3 are opposite each other because that's at the top and that's at the bottom. 2 and 4 I'm considering opposite because one's on the right, one's on the left. So in the picture that's right there, angle 1 and angle 3 are considered vertical angles. And angle 2 and 4 are considered vertical angles. Okay, now the straight line thing will matter because sometimes what you'll see is to kind of test if you get the concept, you might see a problem where they will purposely do something like that, where it's very obviously like a bend in it, and they give you a problem where they say like, oh, there's 1 and 3, are those vertical angles? And it's no, because this is not a straight line. This might be, but this is not. For you to have an actual classification for vertical angles, they have to be two lines crossed. Now, the reason it's important for you to get the identification down is because can you, in here, can you see that there's two acute angles and two obtuse angles?
Yes.
Okay. The acute ones are going to be equal to each other. The obtuse ones are going to be equal to each other. It's like it has to be. There's no way around it. And that's just for the fact that these two together have to equal 180, correct? Those also have to equal 180. Yes? Well, if you got an overlap there, the only way that these two add up to 180 and these two add up to 180 if this is the same number. Because both of these involving you adding angle 4 to it. So 1 plus 4 is 180, 3 plus 4 is 180. If you take out that overlap, you got 1 and 3 being equal to each other, which is actually called the congruent supplements theorem, but we'll talk about that the next time. All right, so make sure you make a note that vertical angles, guys, have to be equal. So identifying vertical angles is big. You have to identify it because I'm telling you, you're just going to take whatever the vertical angles are and set it equal to each other. Anything that's marked congruent or equal, really take note of. Because it's going to make your life way easier in terms of setting up equations. All right, and I'm going to do one problem with this. Oh, maybe I'll do it. 9 o'clock. All right, can I go on past this? Okay. So that's the one I'm doing. So we're just finding the value of x and y here.
Oh,
And those are definitely straight lines. If they're not going to be straight, it's going to be obviously bent, like I said up there. Okay? Yeah.
x is 16.
Why? Why?
It's got to equal 64.
All right. Well, tell me how to set it up.
Then 48, do 64 minus 48.
No. Give me the equation to start with.
Oh.
Don't give me the first step.
68.
No.
64 equals 48 plus x.
Okay. Now, is that okay with everyone? Look, again, these are perfectly straight lines, meaning that these two right here are vertical angles, so they're equal. Now, what you might see coming up here is you might have to solve for x, and they might say something like, justify why you're doing it. Like I might ask you, hey, why are you allowed to set that equation up? You would have to say, you just say something like, vertical angles are, oh my gosh, congruent. Like you're going to, eventually here, within the next few days, you're going to have to get to writing more explanations out. So it's a good habit, at least in your head right now, to get, hey, I set this up because those two angles are vertical angles, and I know vertical angles are equal to each other. And like you said, you subtracted the 48, you got what? 64 minus 48 was?
16.
6. Okay? And then once I know x, there's a few ways I could go about this. The easiest way is generally setting things equal to each other. So I could still take this, the idea that these two, like this angle here, going up and down, those are also equal because those are also vertical angles. So I could do 14y minus 24 equals 8y plus 36 and solve that out. The other way you could do it, if you wanted to, is that's a straight line, correct?
Yes.
How many degrees are in a straight line? So if I know this is 64, I can do 180 minus 64, which is 116, and that'll tell me how many degrees those obtuse angles are. So I could also take like 8y plus 36 and set it equal to 116. All right? So there's multiple ways to do these problems. You're just going to have to figure out for yourself which one's the most efficient and the best for you. Okay? So if I solve this out, since I already wrote this out, I would subtract 8y, correct? Yeah, what's 14 minus 8?
6.
Then what would I do next?
Minus plus 24.
What's 36 plus 24? Quick!
60.
And then y equals?
3.
Good, 3, okay. Yeah. We'll go with that. It's close.
10.
It's a rounding error, that's all.